Hello everyone, welcome to another tutorial video on object-oriented programming in Java, especially targeted for beginners. So in this tutorial we'll talk about the object variables initialization process. So let's create a project first. We call that Java OOP2. So we have created a project. Let's create a package. So left click, right click, new Java package. So we call that OOP. So inside OOP package we create a new class called Java OOP. Then we'll create default constructor. So this is the default constructor. Let's create two private variables. Let's not initialize it. We'll talk about the initialization process. So we created two variables, int and string, which is int and num, int num and string name respectively, which is not initialized. So there's the first thing is to initialize exactly wherever it is, or the second method is to initialize these variables inside the constructor. So this is the another way of initializing. Let's create two public getter methods. We need to have a return type getInt. So return this dot int num. So we create a getter method for the string. So we created two public methods with return type int and string to get two variables int and num. Now the int and num has been initialized inside the default constructor. So we'll go to the main function and we'll call we create an object, so automatically the IDEs will actually import the objects. So let's print out the values and see whether the initialization is actually successful. So we created a separate package called OOP inside a Java source program, meaning with the object called class object Java OOP. We have two variables int and string, which is access specifier called private. Remember, class access specifier is always public, and inside the constructor we actually initializing the two variables, and we have two public getter methods for int and string respectively. So what we can and we are trying to print out the values of int and string. So if this is also the another method of initialization other than the default equals, then we should actually get the values of 100 and Java to the console. So let's run the program. So we got 100 and Java. So this is the another way of initializing the variables in the object-oriented programming constructs of Java. Let's talk about the third one. First is direct initialization with equals like this. The second is inside the constructor. Why I'm saying all this is, especially when you're trying to do a proper project, both for yourself and for commercial and companies in a job, where we have to actually import the packages and the class objects, instantiate the class object with the access specifier called private, and explicitly initialize the class object before use. So we'll come to that step also. So we have to remember what are the object-oriented constructs available in Java, right from initialization to use. And remember Java, where there is no real removing the resources holding by the variables. It is automatically done by the JVM with respect to, with a contrast difference with respect to C++, where pointers is used and you have to explicitly free the resources. In Java there is no explicit freeing the resources unless there is a file object. You have to close the file object typically, or any port, for example web programming, you have to close the port or close the resource whatever is holding. So there is no real explicit destructor in Java. We have to write our own destructor. For example, file objects are open, check whether the file objects are open. If it is open, close it. So we should have an explicit destructor. For example, in C++ we have a default constructor and destructor. In Java there is no default destructor. The function, the method has to be written and to be called explicitly and at the proper time, at the proper place in the flow of the program or in the project. So what we can do here is we can do a private, because we don't provide this init function. It doesn't return anything, so we are using the keyword called void. And int function, we'd like to initialize the variables, so we just remove the initialization, move it to this function, and then explicitly call the function init func. So this is the another way of doing the initialization. So what is the advantage of doing this? During the course of the program lifecycle, you can explicitly call the init function and initialize the automatic values. So if you do equals, it's only done once at the beginning of the object, when the object class object starts executing, and the same thing when you do initialization done inside the constructor. But if we have a function, we can actually call the function of the class object anytime we want and initialize to the actual initialization value. Otherwise we should have a explicit getter setter methods, which is obviously will be there, and actually we have to set the values of the variables, member variables of the class object. So this is just the standard way of providing the functional way of initialization process. So let's run the program. Let's see, we get the same values, 100 and Java. So we got 100 and Java. So this is the another way of initialization done with the member variables using a method, meaning the function, with the return type called void. So what we can do is to go one step ahead, and we go for initialization of another class object. So for that, let's create another Java class, the Java package called let's say class object, and inside the package let's create a class called the parent class. Let's keep the default constructor with the key access specifier called access specifier public. So this is the constructor. There is no destructor in Java with respect to object oriented programming. Let's create a private and value, private string class name. Let's provide an explicit init function so that we can call anytime, just call the function get initialized. So this dot value equals define this dot class name parent class. So let's call this initialization function inside the constructor. So as soon as the class object gets created and starts running, the variables gets initialized. So what if we want to do other than the initialization function? So we have to provide the getter setter methods. So first we provide setInt int. We take the int and value actually. Let's change this to this value. This is the setter function for value variable. So setter function need not return a value, so it's actually void. So let's write a get value getter function. So it doesn't have any variables passed on to the function. So we have a return function, return keyword called this value. So we have two methods now, set value and get value. Set value doesn't return anything, so we put void, and for get value return the value of int, because the variable called value is having a data type called int. So let's just to save time, I have just copy paste and create for this string which variable called class name. So set class name, this class name, so we successfully created 4 functions, 2 functions for each variable, and value is int and class name is string. So we have set value for int and get value for int, and set class name for class string and get class name for returning the string. So we have utilize getter setter for these private variables, and the initialization is done explicitly in the init function. And as far as this class goes, there is a explicit initialization which is already done in the default constructor, meaning as soon as the class object starts running, it gets initialized to value called 55 and parent class. So let's go to the OOP class and let's import the actually the parent class. So what you can do, the parent class object, parent class. Now it is already actually imported to the parent class. So what you can do, come to the initialization function and use the, let's put it as private, so it is not accessible by the class instantiated class object of Java OOP. You cannot directly access parent class. So pc dot we explicitly set value to 77, pc dot set class name to derived. So we have actually changed the values of the class object called parent class, which is a private, and we don't have the thing as we can't directly access the parent class inside the class object called Java Whoop because it's not private. So we have provided initialization function in the Java Whoop class. We were overriding the initialization of 100 and parent class in the constructor called init function, which is called in the Java Whoop, which is the default constructor of the Java class object called Java Whoop. So what we can do is we provide a print function with the access specifier called private public, which does not have anything to return. We just print it out. So we just use the system.out method, the object oriented method, and print it. I'm just looking for name, class name. Okay, so we have a function method which actually just prints out the current value of the variables called value and class name. So what we can do is, after we initialized PC class, so what we can do is we can call PC dot print message. So this will print out the current values. Afterwards we'll set it. So what we can do is, in the OOP class we can actually create a parent object, PCOBJ parent class, created parent class. Then what we can do is we can call print message. So in the parent class we have a print message. Java OOP has been parent class has been an object of parent class has been created inside the class called Java OOP. This is another variable, because this tutorial video we are talking about the variable initialization. This is the standard variables in float, long, double, char, string available in Java, but this is now the next step, which is known as the object oriented initialization. So we created an object of type parent class, which is private, and we have set the values explicitly. So even though this is private, this parent class is will be able to access the public variables of the parent class, public variables of parent class inside the namespace of Java OOP. That's exactly why we can able to do this. So there is no parent class. So what we can do is another print message class. What we can do is we just copy paste. Instead of this, we should have the namespace access specifier called PC. So because PC is now the parent class, not this is actually will be accessing these two variables, but we want a parent class object which is actually PC. So we're actually using the PC dot value, PC1 dot class name. So this is not directly accessible, so we have to use the getter function called get value and get class name. So what we have done is first is the create a class parent class which has two variables, int and string of data type. We have provided initialization 55 in parent class. We have setter, getter setter methods, and we are having a print uh, function which actually prints out the current value of this parent class. In the OOP class, we actually created a class object, and we are trying to print out what is the current value of the object, because we actually override the default values of um, the parent class, because this is now the instance. So the first one actually prints out the actual value of parent class, which is 100 and not 55 and parent class. After we override, it will become 77 and derived class. So what we are doing here, you're actually just doing the printing. So we haven't created a parent class object. We will go for Java OOP. Actually Java OOP is already there. So this is the just to show what is the current value of this. This is another instance of the parent class object. Then we'll print out again print message. So not this. Let's go for obj dot print message. So I'll come back and explain. So what we have done is we have created a parent class which has two variables, initialization function, two getter setter methods for each variable. We have a printing methods which prints the current value. Then we'll come to OOP class, which is Java OOP object. We created a private class object called private class with the variable name called PC. So we are printing that in the constructor of that Java OOP, which will print the current value, which is like it should print 55 and parent class here. And then we initialize that, override the values of the standard value to 77 and derived class, and we have a print message function which actually prints out the current value of the PC, which is actually the instantiated class of the parent class. So we have this parent class. This is independent of Java object. When the Java object is created, we actually have an instance of the parent class inside the Java OOP. So these two are different now. Just to show the initialization process, let's run the program and see whether we got all the values. So first we created object, so it has printed the values of 5500. Parent class, the parent class is accessed. Then we set the value to 100, and this is the actual thing that is coming from this one parent object. So let's do some pretty printing so that we actually bifurcate the displays. So we actually, this first object is running, which has 55 and parent class, because we are actually printing the message here. Then we override to 77 and derived class, and this is the actual class that is actually, which is 55 and parent class. Then we overridden inside this object, so that is overridden values coming at 77 derived class, which is actually here. So what we are trying to demonstrate here is how to initialize and access a class object inside another class object. This is very much important for object-oriented programming, so that you use the class object inside another class object to proceed in the programming constructs as far as Java syntax and semantics is concerned. So there are three ways of initialization: directly here equals, other is to provide directly in the constructor, or you create a function and then initialize it and then call the function. So there are three standard ways of doing it. And then we have now, other than the standard data types, infort, long, double, string char of Java programming language, we have a class object PC. So we were overriding the default values because we have an instance here, and we can actually call that instance inside the class object, because inside the class object any private is like public things. So we are accessing get value and string value inside print message, but when it comes to the main, here it is not visible. This class object called parent class with the variable name called PC is not visible in this object of Java because the access specifier what we provided is private. So we have explicit print message which is actually printed out. So I think I will end the tutorial here. Thanks for watching this video so long, and please stay tuned for the additional videos coming in object-oriented programming in Java. So thanks a lot. Bye.